Hi, my name is Sid Sundaresan, and I am the Senior VP for Silicon Carbide Technology and Operations at Navitas. I came to Navitas through the GeneSiC acquisition in August of 2022. So it was not just me, but also like a team of nearly 20 GeneSiC personnel who made the trip from Virginia to Torrance. Today, you will be talking to one of our very talented device engineers, Dr. Aditi Agarwal. She will give you a rundown of like what makes our silicon carbide trench assisted planar technology tick. But before that, a few words. So we have deep rooted knowledge in both the device design as well as fabrication aspects of our MOSFET technology. We have several patents in the area of not just design, but also fabrication process technology that eventually makes the trench assisted planar MOSFETs. We, in 2015, transferred the process to X-FAB Texas, which is our main foundry partner. And since then, these MOSFETs have been fabricated at X-FAB Texas. So even though we may be a fabless company as compared to the likes of some other big competitors, we are able to compete with these competitors because we have access not only to the device design, but also the fabrication process. So even though our devices get fabricated at X-FAB Texas, it is our process that X-FAB Texas is running. And this makes it very easy for us to make changes to the processes and come up with newer generations of our parts. Okay, with that being said, another question I get asked is like, how, being a smaller company, are you able to compete the likes of some really big companies that exist in our field? Well, we think that what is perceived as our weakness is actually our strength. First of all, as our CEO Gene Sheridan likes to say, we don't have legacy silicon in our portfolio, so we are a pure play silicon carbide, gallium nitride, wide bandgap device manufacturer. So we are able to also, because of our size, be able to make decisions quicker. We are more nimble than the bigger companies, and this is actually like a big part of how we are able to constantly evolve our technology and keep pace with others in the field. Okay, with all that being said, I will now turn the spotlight to my colleague, Dr. Aditi Agarwal. So a few words about her. So Aditi studied with the power device pioneer, Professor Jayant Baliga at NC State University. She has been with the GeneSiC Navitas team for about 2 years now. And she is going to give you, as I said, some deep insights into what distinguishes our trench-assisted planar technology and compared to with other competitors. Okay, over to you, Aditi.
Hi, I'm Aditi Agarwal, and I work in the Silicon Carbide Device Design Group at Navitas. Today, I'm going to walk you through the technological aspects of our device. So there are two types of MOSFETs currently available commercially. The first type is the planar gate MOSFET. Here are some of the cross sections for the planar gate MOSFET. And you can see that in case of a planar gate MOSFET, we have channels being formed on the top side of the device. The second type of MOSFET is the trench gate MOSFET. In a trench MOSFET, we have channels forming on the trench sidewalls. There are two types of approaches in the market currently for the trench gate MOSFET. The main benefit of the trench gate MOSFET is that because of the vertical channel, we can really reduce the cell pitch and include more unit cells per unit area. However, the trench gate MOSFET suffer from a really high electric field and at the corner of the trenches, which reduces the reliability and robustness of the device. So to shield this corner of the trench, our competitors have to introduce shielding structures that are very wasteful of the very expensive silicon carbide real estate. For example, one competitor has put dummy trenches with the P+ region under it, and the other competitor has completely killed half of the unit cell by putting a P+ ion implanted region at one side of the gate. We have, what sets us apart from our competitors is our patented trench-assisted planar gate technology, which combines the benefits of both planar and trench gate MOSFETs. So these are some of the cross sections of actual devices taken from a scanning electron microscope, or SEM. We have introduced a trench in the source region, which helps us pack the cells more tightly and reduce the resistance per unit area, and also faster switching and lower switching losses. We have completely avoided the weaker areas of the trench MOSFET by completely eliminating the corner in the trench sidewall. And because our channel is still on the top side surface, we are still able to retain the reliable and robustness of the gate. The trench MOSFET also has a higher resistance increase at higher temperatures as compared to planar MOSFETs, and this is one of our key points in our device that sets us apart, is that we have better resistance at higher temperatures. Also, since our structure is simple, we can manufacture it in fewer steps and at a lower cost compared to the very complex structure of the silicon carbide trench gate, which is also susceptible to more process variations. So this is at the core of our products and our technology, but we are still improving and building on this structure, and we are constantly improving the process as well.